All right. I hope we have completed the first part of our theory notebook. Let's go through on the first set of questions, okay? The first set of questions will include topics such as the uh, power. It will also include topics such as electrical heating, the calculation of cost, and the renewable and non-renewable energy sources. Okay, so let's look at question one. An electrical heater uses 60 kilojoules of electrical energy in 5 minutes. So this is the energy. So this is energy. This is time. What is the power rating? So they want to find power. So which is the formula? E equals to PT. This is just basically the formula of power equals energy divided by time. What is the rating? You want to calculate the power itself. Just put 60 times 10 to the power of 3 because it's in kilo, so it's 10 to the power of 3 divided by 300. Why 300? Because your time 5 minutes is 300 seconds, so you should get an answer of 200 watts. Answer should be D. Let's look at question 3. An electric fan is rated 60 watts, 240 volts, so they already tell you this fan requires a power of 60 watts and is best if there is a potential difference or EMF of 240 volts. What is the cost of using the fan for one whole day? So you must be very clear, one whole day is 24 hours. Okay. So what if they tell you a unit cost? So this is the unit cost for 1 kWh. So they want you to calculate what is the cost of using the fan. So you want to calculate the energy. So the energy equals to power times time. Take note your power must be kilowatts. Your time must be in hours before we do the calculation. So power times time is here, power times time. Power is 0.060 because you want to convert into kilowatts, remember. Time is 24 hours, you'll get this amount of kWh. This is for energy. What is the cost? You multiply this by the per unit cost, you should get $0.36. Okay, let's look at section B, part A. Alright, figure 19.1 shows an electric kettle that has an operating voltage and a current of 240 volts. So this is the operating voltage and this is the current respectively. Is connected to a heating element. Describe briefly how does electrical kettle work. So they are trying to ask you how is electricity coming into play to make sure that the heating element works. Then how does the water gets hot because this is an electric kettle. So first you got to say the heating element in the electric kettle is made of nichrome wire. Tell us the properties about this nichrome wire. It has a high resistivity. Okay, which means that it has a high resistance. What will happen? The heating element will heat up rapidly when an electrical current passes through it. What happens after that? The water is heated by conduction and convection. Okay. Okay, let's move on to question 2. So what we have here is a filament bulb. Remember we talked about the 3 different lamps itself. This is the old school one where we use a filament. A filament, in this case, the material used is tungsten. So state the energy change that occur. We have from electrical energy is converted into heat plus light. So there are 2 here, heat plus light. Why? Because remember the filament lamp is not efficient. Most of it will be lost as heat. Only a very small amount is converted into light energy. Explain why the tungsten is coiled instead of being straight. Coiled because we want it to have a longer length. By having a longer length, we can generate more heat and able to grow more brightly. So we want more of it packed into a smaller area. Okay, let's look at question 4. Singapore depends heavily on natural gas for her energy needs. Natural gas is non-renewable, as mentioned. We use natural gas a lot. State one significant disadvantage of using the following alternative energy sources in Singapore as compared to using natural gas. There's a lot of answers. These are just suggested. Okay, so wind power, we do not have consistent supplies. It depends on wind conditions. Also take note, Singapore doesn't have strong winds. Our wind speed is very low, so that's a disadvantage. Hydroelectric power, we need a large dam if we want to make use of a hydroelectric power, but Singapore does not have enough space. Solar power is not consistent supply because it's affected by weather conditions. Remember I told you Singapore has a lot of cloudy, inconsistent supply. Nuclear power, we can't discard or we can't put the radioactive waste in another environment without affecting the water sources all around us. Remember, we are surrounded by water, so there is not enough land space for us to dispose of the radioactive waste. But that doesn't mean that we are not thinking about it. We are actually thinking about it. In fact, they do have a plan for 2064, 65, but it's still in the plans, yeah. Still studying it, correct. Okay, let's move on to question 6. A student is planning to replace a 25 watts 240 light bulb. So this light bulb itself have the following requirements: power, voltage. He wants to use the solar power to power it. So he uses this for 7 p.m. to 7 a.m. every day. He wants to use solar cells to power that. Each of the solar cell has a voltage required of 4.5 and generates current of 0.1 ampere. You can buy these solar cells from Taobao. They are connected in series and yeah, they can store energy. So calculate the power generated by each solar cell. So each solar cells, the information is here. The voltage is 4.5, the current is 0.1. What is the power? P equals IV. Remember, write down the formula, write down the formula, write down the formula. Put in 0.1, taking 4.5, you have as 0.0045 kilowatts. Why you want to do so? Because of the next part. So once you have your power ready, you want to calculate the energy used. So energy equals to power times time. Remember, when I use it, power times time, I like to have the habit of writing down the units so that I know what my units must be. 7 p.m. to 7 a.m. is 12 hours. The power is from the top here. So it uses 25 watts. If we were to convert it into kilowatts, that will be 0.0025. Why? Because this is for the light bulb, and then we will have this amount of energy. So how many cells do we need to generate that amount of energy? You take 240 volts, because to power this light bulb, you need a potential difference of 240 volts. Each of the cell can only generate a potential difference of 4.5. So how many of the cells do you need? 240 divided by 4.5, you need 54. Okay. All right. Let's look at question 1 for section C. Explain what is meant by an electric kettle having a rating of 3000 watts and 240 volts. You need to use it, explain it in your own words in the definition. So, but at the same time, you still have to bring the number 3000, bring 240. So it means that this electric kettle requires 300 joules of energy per second, and the supply of voltage must be 240 volts, which is the supply for Singapore. Okay. For the electrical kettle in A, calculate the current flowing through its element. So P equals to IV. You want to find I, just rearrange it, P divided by V. Power is 3000 of the kettle, 240, you can get 12.5. Simple math. Amount of heat it produces in 10 minutes. So E equals to PT. Remember the units, E equals to PT. In this case, they want to state the amount of heat. They did not say in kilowatts per hour. So you convert it into seconds for 10 minutes. And you use the power which is in watts. So you get this answer. What is the resistance? R equals to V over I. You know that you want to power it, you need 240 volts. And the current itself is calculated above here. That is flowing is 12.5. So in this case, the heating element has a resistance of 19.2 ohms. Okay, let's calculate the cost of using the kettle to heat the water for 10 minutes. We have done this before. Make sure that your power is in kilowatts. Make sure your time is in hours. So for 10 minutes, time 10 divided by 60. Power is 3Y3 because above here it states that the kettle is 3000 watts. So you can get 0.5 kilowatts per hour. What's the cost? If one unit costs 24 cents, you multiply accordingly, you get 12 cents. Okay, so this is for question 1. All right, thank you very much.